The solar storm. Every 11 years, the sun grows restless. Dark patches begin to spread across its surface, vast regions known as sunspots, where powerful magnetic fields twist and knot together like tangled ropes of energy. Around these regions, the sun becomes unstable. Giant loops of plasma rise thousands of kilometers above the surface. Magnetic storms rage across the star. This phase is known as the solar cycle. For months, solar observatories have watched the activity grow. Sunspots multiply. Solar flares become more frequent. Coronal mass ejections, immense clouds of plasma hurled into space, erupt one after another. Most of them miss Earth. But during the peak of the cycle, the probability of a direct hit rises sharply. And one day, the sun produces something extraordinary. The active region. Astronomers first notice the region when it rotates into view along the edge of the sun. The cluster of sunspots is enormous. It stretches across a region wider than Earth itself, a tangled storm of magnetic energy darker than the surrounding surface. Even amateur solar telescopes on Earth can see it clearly. Scientists call it an active region. Over the next several days, it grows. Magnetic fields twist more tightly. Instruments detect rising energy levels inside the region. Solar physicists begin to discuss the possibility of a major eruption. Still, no one knows exactly when or how violently the sun will release the energy building there. Then, without warning, it happens. The break. Deep inside the active region, magnetic fields suddenly snap. In a fraction of a second, an enormous solar flare erupts. A flash brighter than millions of hydrogen bombs explodes from the sun's surface. Radiation pours outward in every direction. Satellites instantly register one of the strongest flares ever recorded. 8 minutes later, the radiation reaches Earth. Radio signals across the daylight side of the planet suddenly fade as the upper atmosphere becomes violently ionized. But the flare is only the beginning. Moments after the explosion, something far larger lifts from the surface of the sun. A colossal coronal mass ejection. Billions of tons of superheated plasma expand into space like a growing wall of fire. And the eruption is pointed directly toward Earth. A short warning. Space weather monitoring stations immediately recognize the danger. The storm is traveling fast, incredibly fast. Models estimate that the cloud will reach Earth in less than 16 hours, unusually quick for an eruption of this size. That speed means something else. The storm's magnetic structure is extremely strong. Within minutes, alerts move through international space agencies and power grid operators. Satellite controllers begin placing spacecraft into protective modes. Airlines consider rerouting long flights. But there is only so much anyone can do. Human civilization cannot move the planet. It can only wait for the storm to arrive. The magnetosphere trembles. When the plasma cloud reaches Earth, it collides with the planet's magnetic shield with enormous force. Normally, the magnetosphere protects Earth by deflecting the steady stream of solar wind flowing from the sun. But this storm is far stronger than usual. The magnetic field surrounding Earth compresses violently, pushed inward by the pressure of the incoming plasma. Shock waves ripple across it like waves striking a shoreline. Energy pours into the upper atmosphere. The sky begins to glow. Auroras across the world. Auroras ignite with unprecedented intensity. Brilliant arcs of red and green light ripple across the polar skies. Then they spread. Soon, the glowing curtains are visible far from the poles. Over New York, over Paris, over Tokyo. Cities that have never seen auroras in their history suddenly find their skies alive with moving color. Crowds gather outside to watch. Cameras rise. Social media is flooded with images of the most spectacular aurora ever recorded. But as the sky burns with color, the planet itself begins conducting electricity. The surge. The solar storm distorts Earth's magnetic field, generating enormous electric currents in the ground below. These currents move silently through the planet's crust, through pipelines, through railway tracks, through the vast network of high-voltage transmission lines that carry electricity across continents. Power lines become giant antennas. They begin drawing energy from the storm. Inside electrical substations, transformers start to behave unpredictably. Operators see strange voltage spikes and irregular currents moving through the grid. At first, the disruptions seem manageable. Then, the first transformer fails. The cascade. High-voltage transformers are the backbone of the electrical grid. They regulate the immense flows of power that keep cities alive. But when geomagnetic currents surge through the grid, these machines begin to overheat. Metal cores saturate. Cooling systems struggle. Insulation breaks down. As each transformer drops offline, power is pushed onto neighboring lines. Those lines overload. Failures begin spreading through the grid like falling dominoes. Across multiple continents, electrical networks fracture. Cities flicker. Then the lights begin to disappear. Satellites in the storm. Above the atmosphere, the storm is even more intense. Charged particles flood Earth's orbital environment. Satellites are bombarded with radiation, capable of damaging electronics and disrupting software. Some lose orientation as their control systems malfunction. Others shut themselves down entirely. Navigation satellites struggle to maintain accurate signals. GPS coverage degrades rapidly. Communication satellites flicker offline. The invisible infrastructure that connects the modern world begins to unravel. The first global blackout. By evening, hundreds of millions of people are without electricity. Control centers attempt to stabilize the grid, but the damage continues spreading. More transformers fail as the geomagnetic currents surge through transmission networks. Entire regions disconnect to protect what remains of their infrastructure. Airports suspend flights. Fuel pipelines stop pumping. Digital payment systems fail where communication networks collapse. The modern world runs on a constant flow of electricity. Without it, systems begin shutting down faster than anyone can respond. When the grid lost its heart. Within hours, the scale of the disaster becomes clear. Electricity, the invisible current that sustains modern life, begins disappearing across entire regions. When it goes, the effects spread instantly. Lights vanish from homes and streets. Traffic signals go dark. Cell networks fall silent. Banks cannot process transactions. Hospitals switch to limited emergency power. Computers shut down. The systems people depend on every minute of the day simply stop. Night falls over a planet that suddenly looks very different. Cities that once blazed with light fade into shadow. Highways disappear into darkness. Skylines vanish. From orbit, satellites capture an unfamiliar image of Earth. For decades, the planet had glowed with the lights of civilization, a bright network tracing continents and coastlines. Now, large sections of that network have gone black. The long recovery. Eventually, the storm passes. The sun returns to its ordinary rhythm, but on Earth, the consequences remain. In dark cities, people wait for power to return. Phones cannot charge. Banks cannot operate. Water systems struggle without pumps. Hospitals ration electricity from generators. Engineers begin rebuilding the damaged grid, but recovery is slow. Some cities regain power quickly. Others wait weeks. In the hardest-hit regions, the return of electricity and the systems that depend on it takes months, sometimes years. For a long time, parts of the modern world remain dimmer than before. The star that holds our fate. Civilization survives, but the storm leaves something behind. A quiet understanding that the modern world rests on systems far more fragile than most people ever imagined. And far above Earth, the sun continues its restless motion. Magnetic fields twist across its surface. Energy builds, slowly, silently, until one day, somewhere in that vast ocean of fire, the next storm is born.